In this exercise, we're going to be discussing guidelines for successful constraining. As you create sketch geometry, constraints are automatically applied. However, those constraints do not always completely represent your design intent. Therefore, you must add constraints or delete them to capture your design intent completely. There are several areas that are important when trying to successfully constrain a sketch. First, you need to determine your sketch dependencies. During the sketch creation process, it's important to determine how the sketch elements relate to each other and how to apply the appropriate sketch constraints. So for example, if I was going to sketch out a little shape here, and I know that the end needs to be perpendicular to this line, so I can rub it on there. Come up here. Once again, it needs to be perpendicular. I want this line to be parallel, or I can say I want it to be perpendicular to this line, whatever is more important to the design intent of the sketch. Then I can come down here and I can finish it up. There are a few things that I would know. I know that I want to keep this line and this line parallel to one another, but I couldn't create it just on the fly in that sketch. So that's where you'd come back afterwards and apply parallel constraint. And that gets us to where we want to be. The next thing we need to do is analyze automatically applied constraints. As you create the sketch geometry, some constraints are automatically applied. After the sketch is created, you should be able to determine whether any degrees of freedom remain in the sketch if required to delete the automatically applied constraints and apply new constraints to properly remove degrees of freedom. So if we hit F8 on our keyboard, I now see that this line is perpendicular to the center line. This line and this line are parallel to each other. This line and this line are parallel. This line's perpendicular to this line. And this line is perpendicular to itself. I could say I don't necessarily want this to be perpendicular, so I can highlight it, hit delete. And then what I could do is come in and use a horizontal constraint, for example. Hit F8 again. And so now I have the proper design intent. This object may, for whatever reason, end up rotating off of being perpendicular, or this end here may rotate off of being perpendicular to this. Therefore, I want to be able to adjust how that is in relationship to one another. I always want this to be perpendicular. My other option here would be come in here and always make it parallel to the center. So if this was going to be a revolve, for example, I would want to make sure that that's perfectly perpendicular and parallel at the same time. And that would lock it into that center line. Next, probably the most important thing to remember about successful constraining, use only needed constraints. Don't go crazy here. Keep it simple. Simpler is better. There's 100 little catchphrases you can use to stress this, but simple constraining is always the best. There are going to come times when you need to let sketches flex. We're going to have derived sketches. We're going to have flexible sketches. We're going to have objects that are adaptive so they can change shape and size. So you'll actually need unconstrained sketches. But we want to make sure that we take and give it as many as it needs as simply as possible. This is a nice simple sketch with not too many constraints, but it's locked down pretty good. So make sure when you leave it completely constrained, you do not go overboard and over-constrain it. The next thing to remember is to stabilize shape before size. What that means is we want to figure out what this is going to look like and then start using the dimension commands to shape it and size it. This is not as important if you're using Autodesk Inventor 2013 and above. They've gone in and given you an automatic scale command that scales up the dimension based on that first dimension that you put on it. But it's still pretty important that you want to get the idea of what it's going to look like before you start dimensioning. Next thing is to identify sketch elements that might need to change. Certain objects will actually be adaptive, meaning that you have something like a pipe, for example. You always know what the diameter is. You always know what the outside, inside diameter, what the wall thickness is. That's a constant in a pipe. But the length of a pipe can vary, or a piece of angle, for example. That can vary depending on what you're doing with it. So you may actually have it going between two objects, and you let it be adaptive. What that means is if those objects get further apart, the length of that part will actually lengthen in your design. So if you fully constrain your sketch, whenever you go to lengthen it, it won't let it lengthen. So by leaving certain elements unconstrained, then that leaves it adaptable, meaning that we can change it based on that dimension by some outside force. You always want sketches to be fully constrained, but there are going to be those few exceptions to that rule when you do want it to be adaptive. So think about how you want it to be able to change size. So for example, if we wanted this leg here to be able to adjust in size, I would leave it unconstrained, other than I always want it to be parallel to each other. And that would allow it to basically grow in length, but always be constrained geometrically. We've looked at our sketch dependencies. We know that we want this to be parallel, we want this to be perpendicular. We can analyze the automatically applied constraints. Now you can't really tell the difference in those from the ones you've manually applied and the ones that are automatically applied. There's not a whole lot of difference, other than when you first sketch it out, you hit F8, those are the automatic ones. They don't really do anything different. It's just the fact that they're already there and it's something that you didn't manually think about and take the time to add. So you may want to watch those as soon as you sketch it out, go in and check it. When we talk about using only the needed constraints, one way to see what is still needed is the constraint drag technique. What that means is you come in here and you can grab this and we try to move it in a way to ensure the design intent is captured. Now, constraints are used to control the shape, where dimensions are used to control the size. So my sketch should still be allowed to float around and change size, but it should be fully constrained shape-wise. So I can see that no matter how I move it, the intent of my shape is there. Now there are a few things that may still be floating that I may not like. So what I could do is I could come in here and say this is equal to this. So now it's going to be equal in size. I could say this is equal to this. And then that would lock down my size a little bit more and make sure that it's evenly controlled. What I'm talking about there is stabilizing the shape before I stabilize the size. I'm not necessarily stabilizing exactly 100% of the shape. It may still have some ability to move around and flex and adjust in shape, but this takes me to the step of adding dimensions to fully constrain my sketch. By using the constraint drag and figuring out exactly what I want it to look like or similar to what I want it to look like, I can make sure that everything's in there needed to control the shape of this object. And then that allows me to identify sketch elements that might need to change size in the future. If I wanted this to be able to adjust to be different here versus here, then what I would need to do is make sure that I don't have this equal. Or if I didn't want this to be as tall as it is wide, I would need to remove some kind of automatically added constraints. It's not important to know exactly 100% of everything you're doing when you start. You want to get a good basic idea to it. You can go back into a sketch later on and edit it. Now, we don't want to spend a lot of time when we're designing going back and editing constraints after the fact, but it's better to have to go back and edit something after the fact instead of having it change shape on you whenever you're moving an object around and you don't know why. I have seen parts change shape even after the sketch environment when you're working with features and something happens and you can't figure out why. It's because your sketch wasn't properly constrained and that caused it to be able to flex here and there, and then that changed the shape of our overall part. Those are very hard to identify from a troubleshooting standpoint, so we want to try to avoid that whenever possible. So remember to determine the dependencies, analyze your automatically applied constraints, keep it simple, use only the needed constraints, stabilize the shape before size, and then identify sketch elements that might need to change size. After we master constraining the sketch, then we can move on to dimensioning sketches.